All right, so we're on Unit 4, Lesson 2, and our goal is to determine how many solutions do quadratic equations have. So determine whether each statement is true or false. So it says here 3 is the only solution to x squared minus 9 is 0. Now I'm going to just check that. So I'm going to say x equals 3, and I'm going to check that by substituting. So if I plug in 3 for x, 3 squared minus 9. Let me do some simplifying. So 3 squared is 9 minus 9, which equals 0. Now the question is that the only solution? So we've actually learned how to solve this type of equation directly. So if I have x squared minus 9 equals 0, to undo that, I want to isolate x squared. So to get rid of the minus 9, I'm going to add 9 to both sides. And I would get x squared equals 9. Then take the square root of both sides. And when I take the square root of 9, that would give me plus or minus 3. So in looking at this, 3 is the only solution. This statement is false because we showed there's another solution, x equals negative 3 is also a solution. So here, a solution to x squared plus 25 is 0 is negative 5. That is quite tempting to use a calculator and say that that's true. So if I plug that in, negative 5 squared plus 25. And it says 0, but that's actually doing the order of operations incorrectly. If I want to square negative 5 in a calculator, I have to put it in parentheses because that tells the calculator to do negative 5 times negative 5, which I know is 25, and then add 25, which should give me 50. So this is false. As we showed, negative 5 squared plus 25 equals 50, not 0. So x times x minus 7 equals 0 has two solutions. I know that this is true because this quadratic equation is in factored form, and we set both solutions equal to 0. So we would say, well, x equals 0 and x minus 7 equals 0. So when I add 7 to both sides, we would get x is equal to 7. And then lastly, 5 and negative 7 are solutions to x minus 5 times x plus 7 equals 12. Well, if this said 0, that would be true, but I'm going to substitute 5 and 7 in there. So I'm going to go, well, 5 minus 5 times negative 7 plus 7. Well, that really equals 0 times 0, which equals 0, but it's supposed to equal 12. So that is false. So here, for our second one, this is solving by graphing. So Han is solving 3 equations. The first equation, we're going to call this equation 1. X plus 5 times x minus 3 is 0. And then x minus 5. X minus 5. And here, x minus 5 times x minus 3 is negative 1. And then x minus 5 times x plus 3 equals 4. So to solve the first equation, which is in factored form, we could actually solve this directly and say, well, x equals 5 and x equals 3. He graphed y equals x minus 5 times x minus 3 and look for the x-intercepts. Explain why the x-intercepts can be used to solve that equation. Well, he substituted 0 for y. And we know that the y equals 0 is the x-axis. So the x-intercepts are our solutions. So let's plug in that equation and check. So we have y equals, I'm going to clear out what's in there. And then to model that, we're typing in y equals, and then x minus 5 times x minus 3. So parentheses, x minus 5, parentheses, x minus 3. Close that, graph it. And then we see our two solutions, x equals 3 and x equals 5. If I wanted to find those directly, I could press second calculate. X-intercepts are called zeros. So there is my left bound. Hit enter, and I got 3. And then to do that again, second calculate 0. And then I get 5. So the solutions, x equals 3 and x equals 5. I'm going to draw a picture of the graph just so that when I review my notes, I know what that looked like. So that's a y-axis. Here is the x-axis. Draw 1, 2, 3, 4, 5. Cross at 3, cross at 5, just so I can kind of see what it looked like. Now to solve the second equation, Han rewrote this. And so he rewrote x minus 5 times x plus 3 plus 1 equals 0. And then he graphed x minus 5 times x minus 3 plus 1. In looking at this, this is number 2. So to solve that, he moved the negative 1 over to the other side by adding. And that was equal to 0. Then he plugged in y instead of 0 and then graphed that. So if I'm noticing that, I just need to add a 1 on the end here. And I'm going to graph that. And I'm going to sketch the graph because it says using graphing technology. So my last graph that I did was not so good. So I'm going to improve my sketch. So there's my x-axis, my y-axis. I'm going to calculate my 0. So second calculate 0. Left bound. I need to move my cursor to the left of the 0. And then to the right of the 0. And I notice it's right at about 4. So to do the last one, it says solve the equations using Han's strategy. So first, I need to move this negative 4 to the other side. So I have x minus 5 times x minus 3, and then plus 4 equals 0. To put that in the calculator, I just press y equals, and I need to change my plus 1 to a plus 4. And graph it. And I'm looking for where it touches the x-axis, and it doesn't. So that means there are actually no solutions. And there are no solutions because the graph does not touch the x-axis. So if I'm drawing that picture, I'm just going to draw a rough sketch, and I'm going to write that reason down. So why might it be helpful to rearrange each equation to equal 0 on one side and then graph the expression on the non-zero side? So when you do that, the solutions are x-intercepts and there can be zero, 1, or 2. So now we have to solve each equation. Well, we've actually learned ways to solve each of these. And here, if I'm looking at these three, I'm going to solve using a graph. So if I have to solve x squared equals 121, I would take the square root of both sides and know that that's going to be the plus or minus. So in using a calculator, I just press second quit to quit out of there. Press second square root 121, and I notice I get plus or minus 11. So x equals 11 or x equals negative 11. Then here, same thing. I add 31 to both sides. And then I would get x squared equals 36. Take the square root of both sides, and I would get x equals 6 or x equals negative 6. Here, I can see this is in factored form. So in solving this quadratic in factored form, I'm going to set x minus 4 equal to 0. I don't need to do that for the other one because it would just be the same answer. So I'm going to add 4 and add 4, and I get x equals 4. So I notice for here, I had 2 solutions. 2 solutions. And 1 solution. So to solve this one, it looks like it's in factored form, but I actually need to subtract the 5 over. So I need to graph y equals x plus 3 times x minus 1 minus 5 and look for x-intercepts. So typing that in. I see 2 solutions. X equals negative 1, 2, 3, 4. So x equals negative 4 and x equals 2. So same idea here. I need to move that negative 4 over. So in x plus 1 parentheses squared, what I'm going to do is graph y equals x plus 1 squared plus 4. So clearing that out, typing in x plus 1, close the parenthesis. I can do the squared by pressing that or caret Q2, have that option. And then I'm going to add 4 and graph it. I notice this does not touch the x-axis, so I have no solutions. Same idea here. I'm going to subtract the 990 over. So I'm going to go y is equal to x minus 4 times x minus 1 minus 990. And then I notice I don't see that, so I'm going to have to zoom out. Then I'm going to zoom out again. It looks like I have 2 solutions. So to solve that, I got to find the x-intercept there and there. So I'm going to calculate my 0. And then I notice x is at negative 0.7, so I'm going to just keep moving to the left until I see the cursor pop up there. Oops, and there it did. And then I got to move it to the right. And I get x equals negative 29. So there's a left bound, right bound, and I get x equals 34. So in looking here, analyzing errors, so consider this equation in factored form and having it equal to 7. Priya says that you take x minus 5 equals 7 and x plus 1 equals 7. So the solutions are 12 and 6. Do you agree? Well, her idea, x minus 5 equals 7 or x plus 1 equals 7, I disagree. So what she's using is a zero product property, which only works if the equation is equal to 0. So her reasoning only works if x minus 5 times x plus 1 equals 0. So now it says consider x squared minus 10x equals 0. Diego said you can divide each side by x to get x minus 10 equals 0. The solution is 10. Mai said I wrote the expression in factored form. And ended up with two solutions, 0 and 10. I agree with Mai because she's using the zero product property. So the zero product property works. So once she factors, we would say x minus 10 equals 0. So you could set those two equations equal to each other. So x equals 0 or x minus 10 equals 0. So that means x is equal to 10.